All right, so welcome to today's lesson. Today we are going to continue with our differentiation, where we talk about differentiating from the first principle. So when we talk about the differentiation, what actually are we talking about? We are taking, let's take for example, any arbitrary line. Let's take any arbitrary line from here up to here, and then we consider any arbitrary curve. Okay, any arbitrary curve on this, where we are having curve like this. Okay, this is just any arbitrary curve. Okay, but we know that this is what our Cartesian plane, where this is where the origin. So let's just draw any line through our curve. Okay, so we have drawn any line through our curve, but then this is, let's consider here to be our x. Okay, but let's consider here being our x on the graph, and then let's let the distance between here up to here, h comes here, be some h. Okay, it means that place is h. uh, but let's let our the curve, our y, be equal to some f of x. Okay, so if our y is any f of x, which is a function, we now first have what the x coordinate here to be here, where the second x coordinate to be here, and then the distance between this point and this point is our h. We can now also map that towards the y-axis, where we have here, and then we also have this here. But already we said that our y is equal to what? F of x. So the point over here can be what? Our f of x. Okay. Now, if this is f of x, then what will be the point from here up to here? Okay. Let's take the distance. From here to here is our x, and then from this x to here is going to be what? Our x plus h. So this is going to be our x plus h. This is up to here. So we are now taking from here up to here. This point will be what? Our x plus h. Okay. But here is also what? X. Then here is going to be what? Y. Our y over here is going to be our f of. Okay, let me take that out. It's going to be our y. It is going to be our f of x. Okay. X plus h, sorry. So it means that here will be what? F of x plus h. Okay. Now, when we want to find the gradient of this line, the gradient of this line over here, what can it be? First, let's take, for instance, we have a straight line, and then, okay, that's not drawn to scale. Let's consider it this way. Uh, let's consider it this way, that we have a straight line, and then we want to find the gradient of this line. Finding the gradient of this line, let's consider here to be a certain point A, and then consider here to be a second point B. Okay, now here has two coordinates, x and y. Here also has coordinates x and y. So we are going to find the change in y over the change in x. So it means here can be what? Our x1, y1, where here can also be some x2, y2, which are just some arbitrary points. Okay, now over here, and this is fixed, and then this is also fixed. Okay, so our gradient over here, our gradient is going to be what? The change in y over the change in x. Okay, so what will be the change in y over here? This is going to give us my y2 minus my y1 all over my x2 minus my x1. Okay, that means that we have finally what? Achieved finding the gradient of this line. Let's apply the same concept here. Let's apply the same concept. What will now be what? Our change in x. Sorry, our change in y, which is what? The numerator here. Our change in y, which is going to be what? First point is going to be f of x plus h minus some f of x. Okay. that is going to give us what um that is going to give us our f x plus h minus some um f of x, right? Okay, now let's take the denominator. The denominator, which is going to go our change in x. Now changing x over here is going to be we first have our x and then to x plus h, which means that we are going to take this one being our second point, which is like our x2 minus our x1, and our x2 is x plus h, and then our x1 is x. So it means that over here we are going to have what our x plus h being the second point, then we subtract the first one from it, which is x. Now if we simplify this further, what is it going to give us? We know that this x is going to take away this x. So we're only going to be left with what? Our age over here. Okay. So now let's see the gradient of this function or the curve over there, which is our second line. Okay. That we are going to have one our f of x plus h minus f of x all over the change in x. And our change in x as we have arrived here is what? Is h. But what do we know? We say that differentiation is the rate at which this curve, okay, is changing at a singular point. It's changing at a singular point. But here, this is double point. This is the second point, and then what's the second point? So we are now going to find it where the rate at which it is changing at a single point. Now, at a single point, we are now going to consider shrinking this point to meet our guy here, the first point or a single point here. By that doing, we know that this is the origin. All right, this is our origin. So if this is our origin, we are now shrinking this back. We are shrinking it back. It means that there will be a point that this guy that is here can move up to here, to move up to here, and to move up to here. But we are now moving it to meet a single point over here so that we can find the rate at which it is changing at a single point over here, at a single point. So as a single point, what is happening to h? What is happening to h? You realize that h is shrinking, it's moving back. The h is what? It's moving back. So as it is moving back, and this is our origin, and it is approaching 0. So we now have that the limit as what? H approaches 0. The limit as h approaches 0. So evaluating this, we now have what? Finding how to find the rate at which this curve is changing at a single point to be this function. Okay, to be this function, which is now what? Our first principle. So graphically, that is how the formula came about. So in our next video, we'll talk about how to use this to solve simple examples, complex examples, so we'll be familiarized with this. Thank you.